Okay, we will get a fluid flow Fluent. Right click on geometry, new design model or geometry. It's going to take a minute to load. Sketch rectangle. In the XY, I'm going to do 100 by 100. Actually, let's make that 100 by 50. Let's do it to centimeters, units, centimeters. We're going to do height of 50 centimeters. Let's do 100 centimeter. Nope, got that backwards. Alright, that's good. Now we want to go to concept, surface from sketches, box select, generate. Then we can go back to workbench, and we can go to meshing. Okay, gotta wait a second for it to load. Sure it's in the right. Yep, it's in the right thing. So we want to go to edges. The top edge would be the border. Then you got the flat plate. Inlet. Outlet. And then that would be the airflow. Okay, now we can start bringing in the mesh. Insert sizing. We gotta go back to the edge select. Let's select the inlet and apply geometry. We're gonna do it by number of divisions. Let's do 80. No, we do not need curvature. We want to do hard, and then yes, we do want a bias. And then bias factor, let's do 60. Okay, that's good. Generate. Okay, that's gonna look a little weird. I want to insert another sizing, select the outlet, apply. Element size, number of divisions, 80. We do not need the curvature. high. We want the bias. And then this one will be reverse bias. Okay. Bias factor of 60. Should work. Generate. Now we will do, okay, insert face mesh. That's good. I want to insert sizing and then select the top and the bottom. Do element size, number of divisions. No, we do not need curvature. That's a hard. No bias, number of divisions. I believe it was 80. Should be correct. Okay, yep, it's correct. Okay, so that's all for meshing. Go back to Workbench. Click Update. I'll zoom in a little bit to see it better. Okay, now go to Setup. It's taking a bit of time to load. Probably can close all the fast ones. Oops. Yeah, that's why it was not loading. Okay, double precision. Start. Taking a minute to load. Okay. Okay, go to materials, fluid air. So we're going to do density of 2, viscosity 1.8, so -5, change rate, close. So, let's see. Residuals. Reference values? No. This one is. Okay. let's see. Now I want to go to the boundary conditions. And that should be 2 meters per second. Okay, and then the outlet should already be correct. Okay. The far border, this is when I'm going to change the specific setting. Stationary, no slip, standard. So far border. I'm going to change it from a wall to a symmetry. Let's see, we already got that, got that. Stationary wall. Okay. Okay. Check the reference values from the inlet and the density and the viscosity should be correct. Yep. Okay. We're going to initialize it. Should have 10 values. Well, that was quick. Okay. Run calculation. Let's see. Number of iterations. Set it at a very high number. Okay, once that's done, you go back to Workbench and go to Results. Okay. Gotta wait a second for it to load. Okay. Contour 1. I'm gonna do symmetry 1, velocity u, 110. Okay. Take a screenshot of that. This would be the velocity. Okay. I'm going to unclick on that and then insert a new one. Do it symmetry 1. This one would be pressure 110. Apply. Okay, it's good for that one. Then we will do symmetry, location, symmetry 1. Velocity symbol. Check to see if that works. Okay, yeah, that's too close. So you gotta change this. Try 0.5. Still too close. 2. Okay, that's better. Screenshot of that. So should be off of that one. No, I'm gonna click on that, and then add 2 lines. Line at 35 centimeters. Let's do 1,000, why not? 5. Okay, that's good. And at 75. Okay. And then let's create a graph, a chart. Let's call this one. Okay. 35 centimeters. Data series. Centimeters. Apply. Okay, that is definitely wrong. Okay, that's kind of weird. Okay, yeah, I forgot to change that. That's why. Velocity U, and then. Oop! We just had something blow down the road. Did you hear that? Probably another transformer. Okay, I'm gonna change that. Actually, I'm gonna change both the lines. Let's use 0.25 because there's a bunch of useless information in there. Okay. Actually, change it to even less. 0.15. Okay, that looks pretty good. Okay, that's pretty good. Let's see. Okay, It's pretty good. So, probably should save that. Yeah. Okay, that's good. Okay. And then let's go back to the workshop. Go to, I believe, setup. Let's go to, plots, no kind of plots. Yeah, XY plot. So, do wall fluxes, wall shear stress. Let's see. At the flat plate.
Hey, I'm glad you're home safe.
What?
I'm glad you're home safe.
Let's see. This one would be the okay, and then we'll change that to skin friction coefficient. Let's see. Where in the world? Let's see. Forces. Not that one. Reports. Forces. Okay. And then that information down there is pretty useful. I should take a screenshot of that. This one would be Save as data. Okay, that should be all.